Alright. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And very good morning. So we will continue our class, which is currently we are discussing the final subtopic of this chapter, which is the equation of motion, general plane motion. Okay, so GPM. This GPM is GPM. You are already familiar with this term because we have already discussed about this in the first chapter. And in chapter 2, we have been doing the subtopic based on the type of motion. So we started with translation, which the motion of the object is in straight line. It's either left or right or up down. Or also it can be at an angle. And also we have discussed in the second subtopic, which is rotation, mostly involve rod being fixed at one point and allows it to rotate about that point. And in the last subtopic, we will discuss about general plane motion, which will basically involve both types of motion, which is translation and also plus the rotation. So if you recall, for translation, we have been using three equations, which is the first one is Fx equal to max, and then we have Fy which is equal to MAY. And then we have the moment calculation mg, which is equal to 0 because there is no rotation involved in translation. So alpha equals to 0, therefore mg is equal to 0. So that is the first topic that we discussed. In the second subtopic, we have discussed about rotation. Okay, rotation. And for rotation, we are not using XY coordinate system, but instead we use total force Fn in normal axis is equal to MAN, which is also equal to M omega square R. Okay, and then we have Ft tangential axis is equal to MAT, which is also equal to M alpha R. Okay, and finally we have the moment mg, which is equal to Ig times alpha, or we can also calculate the moment about the fixed point, the center of rotation, which sometimes is written as point O. So MO, for example, is equal to IO times alpha. Okay. And this IO is the mass moment of inertia of the center of rotation. And to calculate IO, we use parallel axis theorem. Okay, we use parallel axis theorem, right? Which is equal to IO is equal to IG plus M times D square. So basically, you still need to calculate IG, and you have to plus with MD square. So that is the rotation problem that we have discussed. So today we are going into general plane motion. So for general plane motion, we will be using the XY coordinate system again. So basically the equation will be Fx equal to MAX. This is one. The second equation will be Fy equal to MAY. Okay, and this time around, not like the translation. For general plane motion, the object is rotating while translating, so both types of motion. So we have mg, which is not equal to 0, but it is equal to ig times alpha. Okay, and if you remember, in the first chapter, when we discuss general plane motion, we also discuss another subtopic, which is the instantaneous center of zero velocity. Okay, instantaneous center of zero velocity, or we call it as IC, okay, of zero velocity, or we call it IC. Okay, so for the calculation of a moment, we can also calculate instead of point G, if we can find the location of IC in the problem, we can also calculate the moment about IC, which we call it as MIC. So this will be not equal to IG times alpha, but it is equal to IIC times alpha. Okay, so when you have IC, which is the point other than center of gravity, to calculate IIC, we still need to use also the parallel axis theorem. So this time, parallel axis theorem will be IIC equals to IG plus MD square. Okay, so in general, these are all the equations that you need to use lah, to solve the problems in general plane motion. Okay, so to understand better, I think we should look at example problem. So let's look at the first example problem, which is question number 1. So let's read the question. The 100 kg cylinder rolls without slipping on the horizontal on the horizontal plane. Determine the acceleration of its mass center. So one of the keyword here is to find the acceleration, which is A, the acceleration A, and its angular acceleration. So what you need to calculate is basically alpha, angular acceleration, and also A, the acceleration of the cylinder. Okay. Now, I want to ask, do you think that this problem has friction or not? Should you consider friction in this problem? Anyone can answer me. Do you need to consider friction or not, based on the information given in the question?
There is friction.
There is friction. How do you know that there is friction?
Because without slipping.
Yes. Okay, good. Because it says rolls without slipping. Rolls without slipping means that there will be friction. Okay, although the friction coefficient mu is not given, but when it says rolls without slipping, you know that this question you should consider friction. However, the mu is not given, so that is one thing that you need to find as well. To calculate the acceleration and angular acceleration, you need to know what is the value of mu. So this is one of the parameter that you need to calculate lah. Okay, so we have all the information. So now we start by drawing the free body diagram. So let's draw the FBD first. So if you look at this figure here, so let's first start by drawing the weight mg. So this will be mg, okay, pointing down. All right, and we will have the normal force, because clearly you can see that the cylinder here is touching the ground, so there will be one normal force here. Okay, so this is, I will write this as NA, normal force. You also have a force P 200 Newton. So force P 200 Newton will be in this direction. In this direction, okay, sorry. Let me zoom in and draw it properly. So you have a force P like that, right? In this direction. So this is force P. And another force that you have here is the friction force. In which direction is the friction force? Anyone? Do you think the friction force should be pointing to the left, this direction, or pointing to the right in this direction? In which direction?
To the right.
To the right. Okay, you say the friction force is pointing to the right. Why?
Sebab dia nak roll ke kanan.
Dia nak roll ke kanan. Okay, this
Ah.
object is, because of the force P, where is this cylinder moving? The cylinder will move to the right, right? This is the direction of the motion of the cylinder. Okay, so in which direction is the friction force?
To the left, to the left.
Okay, to the left. You say to the left. How about the others? Because we know that the friction force. Sorry?
I think friction force is to the left.
To the left, okay. Because generally the friction force is opposing the motion. So if the motion is moving to the right, the friction should be acting to the left lah. Okay, that is generally. But in this case, if I zoom in, can you see that? Okay, if you imagine how the cylinder will roll, of course it is moving to the right, but cylinder will roll this way, right? This is how the cylinder rolls. Can you imagine? The cylinder will roll like this, right? Which means in clockwise direction. That is the direction of how the cylinder is rolling. So because the cylinder rolls in clockwise direction like this, can you see where is the arrow when it reached the bottom of the cylinder? The arrow is pointing to the left, right? To the left. Okay, so this way, because of the rolling motion like this, the friction force is actually acting to the right. Okay, the friction force is acting this way, to the right. To the right. Why? Because the rolling is to the left. Although the object is moving to the right, but the rolling motion, when the object reach the bottom of the cylinder, this is the direction of the arrow. So you can see why the friction is actually acting to the right. So this will be written as the friction force lah, or I can write this as Fr, friction, which is also equal to mu times Na. Okay, mu times Na. So that is the friction force. So we have completed the free body diagram, and you can see that there are 4 forces that is currently acting on this cylinder. So now let's draw the kinetic diagram. Okay, we have the same figure here. So now we draw the KD, kinetic diagram. Okay, how many arrows do you think we should draw in the kinetic diagram? Okay, to determine that, you should ask yourself, oh, sorry, I forgot to, first we need to define the coordinate system lah. So we know that this object is moving to the right. So let's take motion to the right as positive x-axis. Remember, for general plane motion, we are using xy coordinate system again. and we can use y positive upwards as a positive direction of y. So this is our coordinate system. So based on the coordinate system, do you think there is motion in x-axis? Is there any motion in x-axis? Yes or no? Is there any motion in x-axis?
Yes.
Yes, okay. So if there is motion in x-axis, then in kinetic diagram, we will have one arrow pointing in x-axis. So what do we call this? We call this as MAX. Okay, so this is one arrow. Now, do we have motion in y-axis for this cylinder?
No.
No, so no motion in y-axis. So there is no arrow in y-axis. Okay, and this cylinder is obviously rotating because this is a general plane motion problem. So we're going to have one rotation motion like that. Sorry, one rotation motion like this. So we have this and we label this as IG times alpha. Okay, so basically in kinetic diagram, we have two arrows. In the free body diagram, we have four arrows. Okay. So once we have completed this, the next step is to apply the equations. So we start with fx. Okay, let's start with fx equal to max. All right. So we look at the free body diagram. We have the force P in x-axis, and we have the friction force in x-axis. So these two forces, this is one, this is two forces. So both are acting in positive direction. So let's write that in the first equation of x-axis. So we have 200 plus mu times NA, because we don't know what is the value of mu. We don't know the value of NA yet. Equal to, okay, now we look at the kinetic diagram. We have an arrow in x-axis, which is MAX. So we can write that as M is 100, and AX, we write it as AX because this is still an unknown. So in here, if you look closely, we have mu unknown, we have NA unknown, and we have AX unknown. So we have three unknowns in this equation. So we cannot solve it. We cannot do anything about it. So we will move to the second equation, which is Fy. Fy is equal to MAY. All right. Now we look at the free body diagram. We have positive NA, and also we have negative mg. So two forces in y-axis. So we will write NA positive minus mg, which is 100 m, and g is 9.81, is equal to, look at the kinetic diagram, we see no arrow in y-axis. So therefore, this will be equal to 0. All right. So from here, we can calculate the value of NA. Okay, we can write, therefore, NA is equal to, you can bring 100 times 9.81 to the right, and it becomes 981 Newton. So this is the value of NA. Okay. Now, we will then move on to the last equation, which is mg is equal to Ig times alpha. Okay. Mg. So let's zoom in here and look at which force has moment about G. So let's start with Mg. Mg, does it have moment about point G? Anyone? mg, does it have moment about point G or not? This is
Tak ada,
point,
Oh, sir.
tak ada. Okay, so this is point G. Let's draw that is point G. Okay, so mg, no moment about point G. Why? Because mg is exactly at point G. What else? P. You look at force P here. It is exactly at point G. So force P also no moment about point G. Next, the normal force, NA. This is not like the previous calculation that we did in the class. This is exactly also at point G because the touching point is only at one point here, which is exactly at point G. So NA also does not have moment about G. So the one that has moment about G is the friction. And if we take this rotation as positive, which is clockwise rotation, we can see that the friction, this force here, to go to G is rotating in anti-clockwise, going to G. And therefore, this will be negative moment. So we will write minus mu times NA. We know the value of NA already, which is 981, times the distance, which is this distance lah, the distance to G, which is 0.3. So we write down in the bracket also 0 multiply with 0.3 is equal to, okay, now we need to find the value of Ig. Okay, so let me ask you a question. Is this a homogeneous solid or not? How do you know an object is homogeneous or not? How do you know?
Bentuk dia normal.
Dia bentuk normal, and then there is no radius of gyration given. Okay, no kg given. So we know that this is a homogeneous solid. So you need to refer to the table. So I bring the figure of cylinder here. Maybe I will put up here, somewhere here. Okay. All right. So if we zoom in, which one should you take as the Ig? Is it IZZ or IXX, which is also equal to IYY? How does the cylinder actually rotate? How does it rotate?
IZZ?
IZZ.
IZZ, yes. Because the one that you see is actually from this view. You see from this view. That's why you see only a circle like this. So the one that is rotating is this one. Okay, this is the one that is rotating. And how does it rotate? It rotates about Z. This is your Z axis, which is passing through the center of the cylinder. So the rotation happens about Z axis. So the one that you should use to calculate the cylinder, the mass moment of inertia of the cylinder is this one, 1/2 mr square. So we will be using that. Let's calculate it here. So let's write Ig is equal to 1/2 m times r square, which is equal to 1/2 times, what was the r? 100 m, and r is 0.3 square. Okay, so therefore we will have Ig, which is equal to, what is this? How many do you get? 4.5 kg, 4.5 kg meter square. Okay, so this is the Ig. Okay, so once we have the value of Ig, we can substitute in here. This will be 4.5 alpha. 4.5 times alpha. Okay. So if we further calculate this, you will get from here, which is minus 294.3 mu. Mu is unknown. We can bring alpha to the left. Minus 4.5 alpha is equal to 0. Okay, this is what you get from mg. Okay, and you can see from here, we have mu as unknown and we have alpha unknown. Okay, can we solve simultaneous equation with this information that we have? Can we solve simultaneous equation? We have this one equation and we have this another equation. Can you solve simultaneous equations to get all the parameters that we want, that is unknown here?
No,
Why not?
because
Dengan solution.
Sorry?
only one term is in common.
Okay. Wait, how many unknowns do you see?
3.
3.
Oh.
Okay.
1,
3
2,
ke 4?
4.
4. Are you sure 4? We have mu. NA kita dah dapat. NA is 981. Okay. So we have mu unknown, we have AX unknown, we have alpha unknown. So we have 3 unknowns. How many equations do you see there? Only 2 equations, right?
Ada 2 je.
Ada 2 equations. Okay. To solve 3 unknowns, you need equations so that you can solve 3 simultaneous equations. If you only have 2 simultaneous equations, you can only solve for 2 unknowns. So in this case here, it is not possible for you to solve this 2 equations with 3 unknowns. So how do we proceed from here? How do we proceed from here? We need to change one of these unknown so that it becomes only 2 unknowns. Okay, so let's go back to the information that we have here, which is rolls without slipping. What does it mean by rolls without slipping? Okay, I will copy a figure so that you can understand. Wait. Okay, and I will paste it here. Okay. Wait, let me just copy this. Okay. So this is the figure that we have. I will zoom in here. Okay, when it says rolls without slipping, what it means is that, do you understand what slipping is? Slip. Slip means something that is slipping with the ground lah. Dia macam apa yang bahasa Melayu? Yes. Dia macam slip. So dia tidak, kalau you imagine something that is rolling, okay, if you imagine a car, you apply,
Dia tak grip rasa.
Yeah, you apply sudden braking, you apply brake yang tiba-tiba, sudden braking. So your tire will lock and the car will slide on the road, on the ground. That is not that is slipping lah, sliding motion between an object with the ground. But if the car, if the tire rolls smoothly without any slip, that is called rolling without slipping lah. So if in this case, because the question says rolls without slipping, maksud dia the motion ni hanya smooth saja. Dekat bawah ni no slipping between the apa ni the cylinder and the ground. There is no slip occur, no sliding motion. Okay, when it says rolls without slipping, the contact point here between the object and the ground is basically having zero velocity. Zero velocity. This velocity equals to zero at this point. Can you relate? Kalau dekat contact point tu ada velocity, dia tak akan roll smoothly, dia akan slip lah, because the velocity has a when the contact point has velocity, the point itu akan bergerak sama ada ke belakang atau ke depan. Jadi dia akan berlaku sliding motion. But when it says rolls without slipping, the velocity at the contact point is zero. So what does it mean when the velocity of the contact point is zero? What is that point called? Apa kita boleh panggil point ini yang kita dah belajar sebelum ini?
I see.
IC. Okay. So bila velocity zero dekat situ, this is basically the IC. This is the location of IC. The location of IC. Yep. Okay, this is the location of IC. So what is the location of IC? IC is the point where the velocity is zero. So seolah-olah, if we can imagine that as if there is a pin here, a pin connection here, that this thing is as if the cylinder here is rotating about that point. That is what IC means. So kalau kita draw the apa ni, the G, this is point G. If we draw the path that G will move, point G will rotate about that point lah, in a circle like this. Okay, in a circle like this. So the point G will have a rotation in a circle with IC as the fixed point. Okay. So when this is IC, point G will have an acceleration in both direction like this. Okay. One is in tangential axis, which we call AT, The other one is in, the other one is pointing towards the center of rotation, which is AN, normal. Okay. So AT, we know from previously that AT is equal to alpha times R. Okay, alpha times R, which is also equal to, if you can see here, in which direction is AT is pointing? In which axis AT is pointing?
X-axis.
X-axis. So AT here is equal to alpha R, is also basically equal to AX. All right. Now AN is equal to omega square times R, which is also equal to AY, because AN is pointing in y-axis. But in our case here, AN is basically equals to zero, because we know that there is no motion in y-axis. AY equals to zero. So what I want to highlight here is this. We zoom in here. AX in the case of rolling without slipping is equal to alpha times R. So let's write it somewhere down here. Okay, I can write it here. Okay, for rolling without slipping. So you should take note on this. Rolling without slipping. Okay, for rolling without slipping, we have an equation AX is equal to alpha times R. Okay. This you need to know. Okay. AX is alpha times R. So what can we do here? We can use this AX is equal to alpha times R to replace this AX here. To replace this AX in the first equation so that we will have only two unknowns with two equations instead of having three unknowns like what we have right now. So from here, we can rewrite this to become, this will be 100 times alpha times R, which is 0.3. Okay, alpha times R, which is 0.3. So if we write the whole equation again, maybe we can bring this one to the right hand side so that we have similar form as this. Okay, so we will have, I will write in another color, which is we have 30 alpha, okay, minus 981 mu is equal to 200. So this will be our first equation. Okay, that will be our first equation. And then the second equation, from this one, we can write minus 4.5 alpha minus 294.3 mu is equal to 0. So this will be our second equation. Okay, so in these equations, you notice that we have now alpha and mu as unknown in the first equation. In the second equation, also we have alpha and mu as unknown. So now we can solve this equation simultaneously. Okay, 1 and 2. All right, so please try to solve this. What do you get? When you solve this, you should be able to get the value of alpha, which is equal to something, and also the value of mu, which is equal to something. So what do we have? Alpha here should be equal to 4.444 rad per second square, and mu is 0.068. All right, that mu has no units. So this should be our final answer, the value of alpha. And also, we need to also determine the acceleration. So acceleration, we can use this equation again. AX is equal to alpha R. Okay, we can use this AX equals to alpha R. So I maybe write it here. AX is equal to alpha times R, which is alpha, we have 4.444 times 0.3 R. So AX is basically equals to 1.333 meter per second square. So this is another final answer. So we have solved this. We have AX 1.333 meter per second square. We have alpha equals to 4.444 rad per second square. the steps are the same, but an extra information that you need for general pin motion is this, that the contact point for rolling without slipping is the location of IC, and then based on the formula that we know previously from chapter 1, we know that AT equals to alpha times R, which happens to be in the same direction as AX. Therefore, we know AX is equal to alpha times R. So you can substitute AX with alpha R so that you can solve the problem. Okay, do you have any question?
Hello sir.
Yes.
So untuk mu tu jawapan dia negatif sir.
Mu tu jawapan dia negatif.
So kalau negatif maksudnya
Apa, biar je. Negatif, I think it's okay because tapi value sama kan?
sama. So
I
kalau
felt kita ada salah dekat direction.
So kalau negatif maksudnya friction kita ke kiri lah kan?
No. Mu is not the friction punya direction. Mu is just a coefficient.
Oh, coefficient.
Mu is a coefficient.
So kalau coefficient darab dengan normal force? Normal force
Tapi mu
positif?
punya value tu must be positive. So sepatutnya it is positive lah. Although you get negative answer, tapi sepatutnya value dia positive. So you just change to positive lah. Yeah, I think so. Okay, any more question? I forgot to put here that we take clockwise as positive for this one. Okay, any more question? Okay, if there is no question, we can also calculate the moment about IC also can. Okay, we can calculate the moment about IC instead of IG. So if we calculate the moment about IC, what we can eliminate is the mu. If you zoom in the free body diagram, okay, this is point G now. Okay, this is IC. So if we calculate moment about this point IC, then we will eliminate, then NA does not have moment about IC, MG does not have moment about IC because it is in the same direction, and also friction does not have moment about IC. So which leaves us with the force P, and we can straight away get the value of alpha. So let's maybe try to do that. Let's try to calculate moment about IC. I will write it here. Okay. So if we calculate moment about IC, calculate moment about IC. Okay. So maybe we copy the IC figure here. All right. Okay. Oops. So dia tak masuk sekali dengan tu. Jap. Dia tak datang. Okay. It's okay. Okay, so if we calculate moment about IC, the equation will be MIC is equal to IIC times alpha. Okay. This is, I just want to show to you this equation here. We did this one, calculation of moment about G. So we can also, I've said earlier in the class, that for general plane motion, we can also calculate moment about IC, which is MIC is equal to IIC times alpha. So let's try to do that just to see how we can get the value of alpha straight away without having to calculate, without having to do simulation. So if I copy the free body diagram and paste it here. Kenapa dia tak datang dengan gambar ni? Okay, saya tak salah images. Alright. So let's copy this and paste here. Oh, dia datang sekali dengan question. Okay, tak apalah. Alright. So if you look at the free body diagram here, and if we draw a line, that passing through point IC. Okay, let's first draw the IC point. This is the location of IC. Okay, this is IC. All right, so if we draw a line passing through IC like this and passing through IC from horizontal, so we can see that only force P that does not fall along that line. This is another way how you want to determine which force has moment about the point lah. So you can draw horizontal and perpendicular line like what I did here. Okay, like what I did here. You can see that we draw a line like this. Okay, and we can see that mg, Na, and friction falls on the line. So these are the forces that does not have moment about IC because it falls on the line. So the one that has moment is only force P, and if we take clockwise as positive like this, clockwise as positive, so we can write down the equation. So force P here to go to IC will rotate clockwise to IC. So that will be a positive moment. So we can write down then P is 200. So 200 times 0.3 is equal to, now we need to find IIC. So this is where you should use the parallel axis theorem. Parallel axis theorem. All right, which says that IIC is equal to IG plus MD squared. So D here is the distance between these 2 points. This is D, the distance between IC to G. Okay, that is the value of D. So we can go back to get what is the value of IG here that we have calculated, which is 4.5 kg meter square. So you write down here IIC is equal to 4.5 plus the mass of 100 and the distance from G to IC, which is basically this distance lah. This one, this is distance to G, this is IC, so this is the distance, which is also happens to be the same value as the radius, which is 0.3. So we write down here 0.3 square. So therefore IIC will be equal to 13.5 kg meter square. Okay, so that is IIC. Now we can just substitute this in the equation. Okay, so to get the value of alpha, so you put in 13.5 alpha. So you can see that 200 times 0.3, you get 60 is equal to 13.5 alpha. So from this, we can straight away get the value of alpha. Okay, we can get the value of alpha. Therefore, alpha is equal to 60 divided by 13.5. You should get the same value, which is 4.444 rad per second square. Okay, do you get 4.444 rad per second square? 60 divided by 13.5. Yeah. Okay, so you will see that by calculating the moment about IC, will make the calculation a little bit easier to get the value of alpha. Okay, and still getting the same value. Then once you have the value of alpha, you can then substitute in this equation lah, in AX equals to alpha times R to get the value of AX 1.333. So by calculating the moment about IC, you don't even have to find the value of mu. Okay, so that is an alternative way lah for you to solve this problem. Okay, any question about this? Any question?
Sir,
Ya.
dia kalau nak guna parallel axis theorem tu, dia mesti kena ada IC dulu ke?
Dia mesti kena ada apa?
IC.
Tak semestinya. Parallel axis theorem is to calculate the mass moment of inertia pada point selain daripada point G. Dalam chapter rotation sebelum ni kan kita calculate parallel axis theorem. Dalam rotation tak ada IC. It's not about IC. Dia tak ada kaitan dengan IC, parallel axis theorem. Parallel axis theorem is to calculate the mass moment of inertia selain dari point G. If you go back to the first slide yang saya tunjuk tadi, you tengok dekat sini, untuk rotation, kita ada the third equation is mg, which is equal to ig alpha. Tetapi kita boleh calculate about point O, which is the center of rotation. You remember the pendulum yang rotate macam ni. Center of rotation dia di atas, di tempat yang saya pegang ni. Center of gravity di tengah-tengah. Di tengah-tengah rod. So IG adalah calculate pada center of gravity. Tetapi kalau you nak memudahkan calculation, most of the time kita calculate about center of rotation dekat tempat hujung yang saya pegang ni. So this is point O. When we calculate moment about O, dia tak boleh jadi IG alpha, dia akan jadi IO alpha. Then you need to find the value of IO. That's where you use the parallel axis theorem. Same goes for general plane motion. Bila ada rolling on the ground. So kita tahu the contact point adalah IC. So untuk memudahkan calculation kita, macam contoh yang saya tunjuk tadi ni, we do not calculate the moment about center of gravity G, tetapi kita calculate moment about IC. Bila you calculate moment about IC, the equation becomes MIC is equal to IIC alpha. So you need to find IIC. That's why you should use parallel axis theorem. It has got nothing to do with IC. Dia hanyalah digunakan untuk calculate mass moment of inertia I tu, tapi about point lain, not about point G. Okay? Any more question? Ada lagi soalan? Okay. Kalau tak ada soalan, let's move on to the next example, which probably is the last example for today. Okay. So let's read the question. This is slightly different from the previous example, where the previous example is rolling without slipping. This one, we have a slipping motion. Okay, so let's read the question. 20 kg wheel has a radius of gyration about its center, KO, is 300 millimeters. So now you notice that the object is non-homogeneous. Why? Because the radius of gyration is given, and by looking at the object itself, you know that it is non-homogeneous. Dia ada cutouts dekat rim tu dan sebagainya. So this is definitely not a regular cylinder. When the wheel is subjected to couple moment, it slips as it rolls. Couple moment ni, ini yang saya sebut hari tu couple moment. Couple moment means this M here. It is already a moment being applied to the wheel. 100 Newton meter. And the important information here that it says it slips as it rolls. Okay, maksudnya dia bukan lagi rolling rolling yang smooth. Dia akan berlaku sliding between the wheel and the ground. Okay, so ada sliding motion. So it slips as it rolls. Determine the angular acceleration of the wheel. So you need to calculate alpha and the acceleration of the wheel center O. So you need to calculate alpha as well as the A, the acceleration. The coefficient of kinetic friction between the wheel and the plane is mu k 0.5. So definitely this is a friction problem. Kinetic friction is given, and it also says that it slips as it rolls. So we need to find the angular acceleration and also the acceleration of this. Okay, let's start by defining our coordinate system. So we know that the motion is to the right. So let's define x positive to the right, and we can define y positive pointing upwards. So this is our coordinate system, x positive ke kanan, y positive ke atas. Okay, that is the first step. Second step is to draw free body diagram. Okay, free body diagram. All right, from here, we know that we can draw the weight first, mg. Okay, we draw the weight mg. We draw the normal force at the contact point between the ground. This is NA. We have the moment, couple moment. This is also a force lah, a couple moment M. Okay, a couple moment M. And also the friction. Okay, tadi saya dah explain when the rolling is rolling clockwise, then the friction will be pointing to the right. Okay, the friction will be pointing to the right. So you will have a friction force pointing to the right. This is mu times F. Mu times NA, sorry. Mu times NA. Okay. Which is mu K lah in this case, mu K. Okay, so this is our free body diagram. So now let's draw the kinetic diagram. Okay, we will have the same figure here to draw the kinetic diagram. So now it's KD. Okay, so how many arrows do you think we should draw in the kinetic diagram? Do we have motion to the right?
Yes.
Yes, so we draw one arrow pointing to the right, and this is MAX. Okay, do we have motion upwards or downwards?
No.
No, right? No motion upwards and downwards. And we have a rotation, so we're gonna draw a rotation like that. We draw a rotation, and this will be IG times alpha. Okay, so that completes kita punya free body diagram and kinetic diagram. Okay. So let's start by writing the first equation, which is fx equal to max, right? So we look at the free body diagram. We only have mu and a in x-axis, which is positive. So mu, we know the value of mu, which is 0.5. Mu k is given. So 0.5 Na is equal to max, which is 20 times ax. Okay. So we cannot solve this yet because we have Na unknown and also we have ax unknown. So let's go to the second equation. Fy is equal to may. All right. So we look here, we have Na positive and we have Mg negative. So that will be written on the left-hand side of the equation. Na minus Mg, which is 20 times 9.81, is equal to, look at the kinetic diagram, we don't have anything in y-axis, which means that this is equal to 0. So from here, we will get the value of Na, which is equal to 196.2 Newton. Okay. All right. So once we have this value, we can substitute this in this equation here, in the first equation, to straight away get the value of ax. So from here, we can get the value of ax, which is equal to 0.5 times 196.2 divided by 20. So the value of ax will be 4.905 meter per second square. Okay, so we have solved the first part of the question lah. So ax is already known. Okay, next we move on to mg. Mg, which is equal to Ig times alpha. Okay. Okay, before that, before I move to Mg, when it says slipping occur, or it slips as it rolls, when slipping occur, it means that this location, okay, for slipping occur, this contact point is no longer IC for slipping occur. For slipping, that point is no longer IC. That point is no longer IC. Therefore, the equation that we have before, which is AX is equal to alpha times R, this is not applicable, cannot be used anymore for slipping occur. For slipping occur, we cannot use this equation. AX is not equal to alpha R because now it doesn't have a smooth rolling at the bottom, at the contact point. The velocity is not zero, it has value, and therefore it slips on the ground. So the equation is not valid anymore. So to solve this, the only equation that we have is basically the friction equation. So we know that friction is equal to mu k times Na. Okay, mu k times Na. So this is the one that we we use to get this value lah. Friction is mu k times Na. All right. So let's go back to the calculation of mg here. Mg is equal to Ig alpha. So if we draw like what I did before, if we draw a line, we know that this is point G. Okay, let's write down where point G is. This is our point G. I'm going to use blue color. This is point G. Okay, so let's draw a line passing through point G. Okay, passing through point G. This line, vertical line, and also horizontal line. Okay, so let's erase this one so that it will, NA should be exactly at this. Okay, so let's draw again the line. Okay, bolehlah NA tu lari sikit. Okay, so the one that falls exactly on the line does not have moment about point G. So MG no moment, NA no moment. So the one that we have is mu NA and also the moment 100 Newton meter. So if we take clockwise as positive, okay, we take clockwise as positive. So we can see that 100 Newton meter moment is positive lah because it rotates clockwise. So we have 100 moment doesn't need to be multiplied with a distance because it is already a moment. The one that you need to multiply with the distance is mu and A, the friction. And the friction to go to G, it will rotate anti-clockwise like this. So that will be negative lah. So minus mu is 0.5. NA is 196.2. And the distance is 0.4. Which is equal to Ig. Okay, now we know that this is a non-homogeneous. The value of KO is given. So Ig is equal to KO given here is also at point G. Okay, so if I zoom in, the value given is KO because point O is also happens to be at the same location as point G. So we can use that KO. So which is 0 m times kg square, m times kg square, which is m is 20 times 300 millimeter. You need to convert to meter, divide by 1000. So it becomes 0.3 square. So Ig will be equal to 1.8, right? 1.8. Okay, 1.8 kg meter square. Okay. So that is the value you put in here, 1.8 alpha. Okay. And therefore we can get the value of alpha from this 100 minus 0.5 times 196.2 times 0.4. And then you divide by 1.8. We will get the value of alpha is equal to 33.76 radian per second square. Okay, so that is the answer of this problem. So we have AX and also we have the value of alpha. All right. Any question? Any question? So basically today I have shown two examples. One is rolling without slipping, where you need to use this equation. AX is equal to alpha R. This is for rolling without slipping. And the second example is slipping occur, slips as it rolls, which the contact point is no longer IC because that point doesn't have zero velocity anymore. There is a value of velocity over there. Therefore, slipping occur as the wheel rolls, and the equation that we have just now, AX equals to alpha R, is no longer applicable in this case, and we need to use the friction calculation, which is mu k times NA, to calculate the friction force, and you can get the value of AX as well as the value of alpha. The rest are the same, only a little bit different here and there. Okay, any question so far? No questions?
No, sir.
All right. So if there is no question, I hope everything is clear. I will share this recording in Kalam so that you can play back again if you want to understand more. We will continue on Friday. Perhaps I will do 1 or 2 more examples on this topic, and then we will be finished with chapter 2, and perhaps the second half of Friday's class we will go into the new chapter, which is chapter 3. Okay, if there is no more question, I thank you for joining the class today, and I will see you on Friday morning.
Sir,
Yep.
if not mistaken, the Kalam will be stopped tomorrow. Can't be used until the 1st
Oh,
of Jan.
Kalam, okay. Tak apa, if until bila?
1st of January.
Okay. So if that's the
Until
case,
next year
I
lah.
will share the recording with you in the WhatsApp group also. And later when Kalam is back online, I will also put in Kalam lah so that you can refer. Okay? Any more question? Okay, kalau tak ada, that's all for today. Thank you for coming to the class. I will see you again on Friday. Assalamualaikum and have a good day.
Thank you, sir. Wassalam.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Welcome.